So it's kind of an exciting time for me today because I'm telling you all about something that I've been working on for a long time. I think well over a year. Not actually working on it for a year, but it's been over a year since I started the project, and I'm super happy with it now. I'm happy to share it and tell you about it. And it's what I call my WallPlateMate and the FlexPlate, which is this part here. In the latter part of the video, I'm going to try and show into the design environment of what I've done with this, and yeah, let me know what you think. It allows you to attach accessory to the wall, and you can do it with or without a wall plate, but I think the most exciting thing is that any switch wall plate that you currently have, whether it's an outlet or switch, you can replace the plate with this flex plate on it and then snap on accessories. This accessory will hold glasses, stick a wallet in it, hang your keys on it, and you can even put a baseball hat on it. So I love this accessory. It's great by my door when I come into the house. You can put a remote control holder there. You can put just a general platform that you can throw your keys on. The heart of the WallPlateMate is this flex plate, and the flex plate has two rails, one on each side, that the accessory slides onto, and then these two prongs on either side that lock into the accessory. To release it, you press on this top part and it flexes. There's a rhombus spring here, and you flex the rhombus spring by pressing that down, and that withdraws these two tabs. So I'll use this red one because it makes it easier to see. From the back side, this slides in, and those just push in, and then now it's locked on. And when I press this, they withdraw, and I can pull it off again. So you can use the wallmate plate as a wall plate replacement, or just as the flex plate. You can screw this to the wall. Once you're finished with it, or you decide I'm moving, or I don't like that anymore, you just unscrew it, put the original faceplate back on. The wallmate plate can be installed, as you saw previously, down or flipped up, so you can put things above the switch. In this case, the remote control holder is above the switch plate because you don't want this to interfere with the switches, so you put it above. I also have created a double-sided wallmate plate so you can have things above and below your switch, which is really the ultimate. So remote control holder maybe on the top, your keys and glasses on the bottom. I think you get the idea. Lots of potential, lots of opportunities. I'll show you, just flash through a few of my installations that I have played around with here. Of course, there's the electrical outlet. You just pop on a faceplate for charging, generic, fit a couple of devices. In the bathroom, somewhere to place your rechargeable toothbrush for an air conditioner remote control. And at my main entrance, I needed a coat hook, but in the winter when I walk my dogs, I get my gloves and toque get really wet, so I just needed somewhere to dry those. So I created a little drying rack, but as you can see, you can just pop those parts in and out and put in a different type of coat rack for bigger jackets. In the powder room, somewhere to put your rings and watch when you're washing your hands or using the bathroom. Maybe somewhere for your air freshener. The possibilities are endless. I mean, I'm thinking you could put a fire extinguisher attachment on it, umbrella hook, camera holder, your clock holder. I mean, the list goes on. And so I hope over time I'll continue to make more attachments for it and increase its functionality. And maybe other people will too, I don't know. I recognize that the wall plates used in North America are not typical of the entire planet. So for those of you who don't have this type of wall plate, obviously this may not be so appealing, but you can still use the flex plate and all the accessories because both the flex plate and the wallmate share the same mounting format. So everything's compatible, and as the product offering grows, it'll have more options available. I know a lot of electrical outlets around the world, the faceplate is attached to the electrical appliance. So you can't do what I'm doing here, but maybe there's a way to attach to those, or In other circumstances, there may be different types of wall plates or face plates on the electrical outlets that I'm not aware of, and maybe we could modify for those. And also, if you want more information, definitely check out my blog. It's really hard to put a video together like this to cover something with so much. So check out my blog, and also I'm building a wallplatemate.com page to just keep it all organized there. So check those out. So before I start talking about some of the design of this product, I just wanted to show you a few more little things, and then if you're not interested in design, you can tune out. But these are examples of my original kind of implementation of this product that I think now all come together quite well, and I think will grow over time, because every time I design something now that's suitable to this type of mounting system, I make it compatible, so it just keeps growing for me. In my shelves, I designed the same mounting rails that I could put other fixtures on, for example, flashlights and tools and snap-in holders. This is a standard plate for, camera lighting. I got the Wise camera mount there. And all of these are, again, compatible with just the flex mount. This is the example of the FlexPlate just being used, and that's where I usually put my camera when I'm filming. So yeah, you get the idea. Currently my design environment is Shaper 3D, which I'm a pretty big fan of. I like a lot of things about it. When I first started this concept, I'm just loading this file to show you, I had a very primitive concept, which was basically the keyhole, and then on the back side of the accessories, I had to install screws. I started assembling it, it was finicky, and I really didn't like it, so I abandoned that. But it was about that time that I was also working on something completely different, which I'm going to jump over to, which was this, and essentially a small plate that I could mount to the wall, and once on the wall I could swap off and on different designs. And part of it was because I knew my designs needed a few iterations, so these were for flashlights and flashlight holders, and it's one of those things you can measure it and design it all you want, but until you print it and use it, you don't really know if you've gotten it right. So it took me a few iterations, so I printed them and I could install this plate once and then snap on different attachments, and eventually got that right, and I was really thrilled with that. And I'm still using this original version today. This was the very first implementation for me of this system. I just wanted to mount these flashlights and the flashlight charging stands, and so you can see it's that little version. It's smaller than the final version, but it's exactly the same in functionality, and it works so well. But now everything I'm designing, I do accessories all to use the new system so that everything's compatible. So this is where it started, and it was about the time I got frustrated with the screws in the back of the other one, where I realized, why don't I put this part onto the wall plate, and then I don't need any more hardware. And it was kind of interesting from a design perspective too. I at one point was kind of intentionally using hardware in my designs, and I thought that would help me to make a more professional or kind of mature feeling product when you're using screws and bearings and springs and things. But in hindsight, I didn't really go very far with that, because in fact, every time when you take it off the print plate, the more work you have to do afterwards, and the more parts you need is just a barrier to the success of the product. And so my focus has been more recently on making things that either come right off the build plate ready to go, or they snap together very quickly and easily with no additional hardware. And honestly, I find that to be much more gratifying and a higher usability of the product. So I think it's pretty obvious that for the most part, this product is all about the FlexPlate, this mechanism, which I'm circling here. All of the wall plates, I just basically replicated the generic design of the different types of outlet and switch plates, and then modified it so that I could add on the FlexPlate. So I don't think we need to talk too much about that, but the FlexPlate itself is, I think, maybe more interesting and worth taking a hard look at. This design is actually pretty simple. There's not a lot to it. The first step is just the creative. There's a history to this and how I arrived here. It evolved, and so it's not like I sat down and said, okay, this was what I'm going to do. But at some point I decided I wanted a little mechanical locking mechanism, and I also had in the back of my mind that creating a one-piece design that was sprung was doable. And so eventually I came up with this rhombus shape here. Essentially the concept is you press down on the top, that forces the far end of the rhombus out. This end's anchored, and so these two arms have to just straighten out, and when they straighten out they retract the prongs. Unfortunately, because this end's stationary and this end's moving, they actually move slightly down when we're looking at it in this orientation, and that complicated some of the clearances, but it's a very small amount, so it's not a big deal, and it doesn't interfere with the success of the design. So essentially, once the locking concept was conceived, it's just a channel. So if we look from the top view, you can see the front part is just a big channel, and so this is a blank. I should have started out by saying this is just a blank mount. So when I start a new design, to design a new accessory attachment, I just start with the blank, and then the blank becomes or solves the back side of it. I don't have to redo that every time. It's just there. So the front piece is just a channel, and the FlexPlate has these rails. So those just engage. Those very, very simple. And this prong extends into the opening right here on the side. So very simple. When you press down, these withdraw and you can slide it off. To make that all work, pretty typical clearances required. I'm using 0.3 millimeters on each side of the rail and a 0.4 millimeters on the side to side. So same over there. And that gives a pretty comfortable fit. It's kind of like a semi-snug fit. You'll feel some friction, but you should be able to slide it up. So to make this part, there's really two design features or design elements. One is bridges, and the other is the sliding parts. And so we've kind of covered the big sliding parts. On the smaller sliding parts, like this prong, when it withdraws, there's some clearance. So we've got 0.3 millimeters here, and I've allowed 0.7 millimeters there. And there's more there because, as I said, when the rhombus is extended, this naturally wants to come down with it. And so I needed more clearance here, but I wanted this to be tight because this is the surface that engages the prong if you try and pull the accessory off without first depressing the pressure point there. So that's key. On the bridging side, of course, we're bridging over this part. And normally I would do, for a bridge, I would do a 0.2 millimeter gap, but I've made a 0.4 millimeter gap here because this is a pretty short bridge and it's not going to drop at all. And that meant that there's zero fusing between this part and this part. And so when it comes off the print bed, it's good to go. You don't have to try and break it free or work it at all. In the ends, there was something a little unusual here where can't recall when I've done this before. I've got a part running through another part, so it's double bridged. It's bridged here on this face is a bridge to go through there, and then inside in here is another bridge right there going across it. And I did that because I wanted some material on this side. Otherwise, when you push down on the pressure point there, this naturally wants to flex out, but this keeps it contained. And so even though you apply a lot of pressure, it stays very stable. And that was quite successful in the design as well. Multiples. I always design in multiples. So if my layer height is 0.2 millimeters, the thicknesses are always multiples of 0.2, and that gives you very good predictability on how things finish from layer to layer. And then also on thicknesses, I do multiples of 0.4, so that's a 1.6. Everything should be a multiple of 0.4 in here, 8. So yeah, we can predict the slicer's behavior and the printer's behavior better if we keep 2 multiples of the print components. Of course, it can do it if you don't. It's not a problem, but I find a little bit better repeatability and predictability of how the design is going to finish. One more thing I want to show you for this one, and it's a real basic concept, not specific to this, but when I'm designing, I never design a hole when it's a symmetrical product. So I actually designed this product like this. And this solves a lot of things, but the main one is making sure you don't have any differences from side to side. Because sometimes you'll be, when you're designing, you go, okay, well, I want to chamfer this, or set this off, or do something, but you forget to do it on the other side. And so you end up with differences that then can multiply or manifest into other problems. But by designing in a half, and then when I'm comfortable with this or happy with it or want to give it a test print, then I mirror over the first half, print it, and go from there. And if needed, I split it again and go back to the drawing board. So this is super good technique to speed things up, because of course I'm only drawing half as much. You can sometimes even do quarters. This product you can't, but in some products like my Lazy Susan mechanisms, I did them in quarters because it's just even more efficient to just keep it as small as possible, more manageable. I should say one other little thing, which I do a lot of things in my own little bubble, so I don't know if it's valid or not, but because this is a smaller piece here that gets stretched and flexed, I wanted it to be very strong. And by chamfering it, of course, sometimes you chamfer just to prevent your first layer squish from becoming a problem. Like here, these are both chamfered. And, if there was a big first layer squish, they might join. But in this case, the reason I've chamfered this is because when the first layer prints, it'll obviously fill this. It looks like about 0.8 millimeters. And then a 0.4 millimeter chamfer means the second layer, 0.2, is shift over 0.2 millimeters. And therefore, the first run and the second run are not directly above each other. They're going to be offset by half of the nozzle width. And then the third layer, which is at the end of the 0.4 millimeter chamfer, is offset again. And so the first few layers strength will be, I believe, better than if you just stack them all straight up. You can actually see that effect here in the middle of the screen. The first 2 runs are already down right here. And as we go up layers, if I go up 1 layer, there you can see now there's 3, and so they're inherently offset from one another. And then when I go to the third layer, there's 4, and so they're offset. But if I go past that, you'll see they just stack on top of each other. So if I hadn't chamfered the bottom there, all of the tool path would have been completely above each other. So each line would have been layered directly upon each other. And probably I should have chamfered the top of it as well. But anyways, there you have it. So thanks for hanging in there with me. Sorry it's a long video. Appreciate you watching if you made it this far. And hopefully I'll have lots of other things to post in the future. The ones that I think are useful, I'll slowly get them posted. Thanks again.